Hi everyone, in this lesson we're going to be talking about imaginary numbers. And imaginary numbers arise naturally from trying to find solutions to equations such as x squared plus 1 equals 0. And in the past, if we tried to solve that, we would move the 1 over, and we would take the square root of both sides, and what we would end up with was a negative under the radical. And at that point we would say, okay, well we're only working with real numbers, so we're kind of dead in the water with this one. We're going to stop. And what happens now is we have decided in this lesson that we're going to define the square root of -1 as I. So from now on, we're not stuck. We can keep moving, and that's the purpose of imaginary numbers, to allow us to proceed even when we end up with a situation where we have a negative under the radical. So just as a reminder, I have this picture here about complex numbers. So complex numbers include real numbers and imaginary numbers. And we've been working with only real numbers up to this point. Now we're going to be including imaginary numbers. And imaginary numbers look like -4i, 3 plus 2i, 2i root 2. Okay, those are all examples of imaginary numbers. So let's take a look at simplifying imaginary numbers. So imaginary numbers can be simplified using the letter I. So for example, if we had, let's say, the square root of -3, we don't want to leave it like that. That is not considered simplified. What that really means is that means we have the square root of -1 times 3, which means the square root of -1 times the square root of 3. And we know forevermore that whenever we see the square root of -1, we're going to replace it with I. So our final simplified answer for this example would be I root 3. So simplify each number using I, right? We have the square root of -2. That's the same as -1 times 2. That's the square root of -1 times the square root of 2. Square root of 2 can't be simplified anymore, so we're going to leave that alone. And now we know that the square root of -1 is I, so we get I root 2. So the negative part under the radical has been replaced with I. And then, of course, we still have that root 2, so that stays there. All right, let's look at the next one. We've got -1 times 36. That's -1 times root 36. The square root of -1 is I. The square root of 36 is 6. We like that. So the final answer here is 6i. And again, the part that was the square root of -1, that just got replaced with I. All right, next one. We've got the square root of -1. Now I'm going to break apart that 18. I know that 18 has a perfect square factor of 9. So I'm going to write this as 9 times 2 instead. So what do I have then? I have the square root of -1 times the square root of 9 times the square root of 2. The square root of -1 is I. The square root of 9 is 3. And there's not anything else we can do with root 2. So our final answer here is 3i root 2. And again, the square root of -1 part is right here with the letter I. Now, most of the time we like our complex numbers to be in the form a plus bi. All that means is that we're going to put the real part first and the imaginary part second. So let's look at some examples. Well, we have the square root of -9, and we have the real part of the number is 6. So 6 is going to come first, and the square root of -9 can be written as 3i. So this first one is going to be 6 plus 3i. Now just remember, I broke apart that -9. That's -1 times 9. That's -1 square root of -1 times the square root of 9. that's just 3i. All right, so the imaginary part is here, and the real part we like to put first, that's the number 6. Okay, if we look at number 5, we have the square root of negative 1 times 3. That's the square root of negative 1 times root 3. That's I root 3. So when we write this in complex number form, we're going to put the real part first, that's 2, plus I root 3. Okay, the imaginary part comes second. Right, now let's take a look at the complex number plane. So you can use a complex number plane to represent a complex number geometrically, just like we would a real number on the real number coordinate plane. Locate the real part of the number on the horizontal axis and the imaginary part of the number on the vertical axis. So let's make a note here. So this is the real axis, and this is the imaginary axis. Right, let's look at some examples. Graph the following in the complex number plane. So we want to graph 3 minus 4i. So first we're going to find the real part. Let's label this again. This is the real axis. This is the imaginary. I'll do this one in red. 3 minus 4i. We're going to find the real part at 3. We're going to go down to minus 4i. So that would be 3 minus 4i. I'll do this next guy in blue. We're going to find negative 2, and we're going to go up to 6i. And that would be negative 2 plus 6i. So just remember that the real part is the x-axis, and the imaginary part is the y-axis. So now we've gotten through all the basics of understanding a complex number. Now we're going to look at the absolute value of a complex number. The absolute value of a complex number is its distance from the origin. Absolute value always means distance from the origin. Now we're just looking at it in terms of a complex number. And you can find the absolute value of a complex number using the Pythagorean theorem. And you can see why in this example that I have below. So first of all, we want to plot the number 5 plus 6i. So we go over 5, we go up 6, and here we have it plotted, 5 plus 6i. Okay? And you can see that we're trying to find the distance from the origin. And we're going to need the hypotenuse of the right triangle. And we know that we could use the Pythagorean theorem, c squared equals a squared plus b squared. And we're trying to find the c side, right? We're trying to find the hypotenuse. So we would take the square root. That would give us c equals the square root of a squared plus b squared. So when we're looking to find the absolute value of a complex number, all we're going to do is take the real part of the number and square it. That would be considered your a part. And the b part of the number, and we're not going to include I. We're just talking about distance. We wouldn't say the distance is 6i. We're saying that the distance is 6. This would be our b part of our number. So in this case, the absolute value is the square root of 61. All right, so let's do some together. So first of all, I'm going to rewrite number 8 as 0 plus 5i. All right, just so I have it in the form I needed it. We know that this is a and this is b. So to find our absolute value, we're going to do the square root of a squared plus b squared. So in this case, it's going to be 0 squared plus 5 squared. Now remember, don't include the I. When we talk about distance, we're just going to use the numeric part of the imaginary number. We don't want to include I. We end up with the square root of 25. That gives us 5. So the answer to number 8 is 5. At this point, I would pause the video and I would try to do 9 and 10 on your own, and then come back when you're ready. All right. This one, a is negative 2, b is 5. I'm going to have the square root of a squared plus b squared. That's going to give us the square root of 29. And the last one, a is equal to 6, b is equal to negative 4. So we're going to have 6 squared plus negative 4 squared. That's going to give us a value of the square root of 52. Now that's a perfectly fine answer. You can simplify that radical further if you want to. A lot of times the answers in the back of textbooks has it simplified. So let's take a look at what we would do to make that happen. All right, so the greatest perfect square factor of root 52 is going to be the value of 4. 4 times 13 gives me 52. So root 4 is just 2. There's nothing we can do with 13 under the radical. So we could simplify the radical as 2 root 13. Either of these answers would be acceptable to me. I just want you to see that how that process works for simplifying under a radical, because again, like I said, a lot of times the solutions in textbooks or in IXL will be in simplified radical form. Right, now we're going to take a look at the additive inverse of a complex number. And all it means is you're just looking for the number that you would add to the original number to get 0. So if the sum of two complex numbers is 0, then each number is the opposite or the additive inverse of the other. So what we want to find out, and this is actually probably sounding a whole lot more complicated than it is, all we really want to know is what number would I add to negative 5i to get 0? And of course, I would add plus 5i. So 5i is the additive inverse of negative 5i. And in number 12, negative 4 plus 3i is the additive inverse of 4 minus 3i. So if I had 4 minus 3i plus negative 4 plus 3i, I would end up with 0. So this is our additive inverse. Okay, moving on to the last page. All right, we keep stepping up the difficulty here. So we're adding and subtracting complex numbers. When we're doing that, we're going to combine the real parts and we're going to combine the imaginary parts separately. So we may want to rewrite number 13. I'm going to rewrite it as 5 minus 2. And then so I'm putting the real parts together. Now I'll put the imaginary parts together. We're going to combine the real parts. Then we're going to combine the imaginary parts. And this one, we're going to get 3 plus 13i. For the next one, I'm going to distribute the negative first. The real part is 4. The imaginary part is minus 2i. Right, that takes care of adding and subtracting complex numbers. Just remember, you keep the real parts together and the imaginary parts together. All right, multiplying complex numbers. When we start multiplying complex numbers and we see an I squared, we are going to replace it with negative 1. Remember, if we have I is equal to the square root of negative 1, if we were to square both sides, we would end up with I squared is equal to negative 1. So anytime we see I squared in our problem, we want to replace it with negative 1. And we're just going to go ahead and FOIL like we always would here. So first, we've got 24. Outer, 6 times negative 3i, that's negative 18i. Our inner is going to be negative 5i times 4, that's negative 20i. And then our last, it's going to be plus now. Negative 5 times negative 3 is 15. And I times I is I squared. All right, so this is what you're looking for. Whenever you see I squared, you're going to replace it with -1. So we have 24. Now negative 18i minus 20i, that gives me negative 38i. And now I have plus 15, and I'm changing over that I squared to -1. So what do I have? I have 24 minus 38i minus 15. So 24 minus 15 is 9 minus 38i. So that's my first answer. All right, I would try number 16 on your own and then come back when you're ready. All right, we're going to do the same thing, first outer, inner, last. Okay, that I squared is what we're going to want to replace with -1. So we have 16. These are like terms, so plus 12 minus 36i. That's going to give me minus 24i minus 27 times -1, right? I'm replacing my I squared with -1. So I get 16 minus 24i plus 27. And 16 plus 27 is 43 minus 24i. So that's my final answer. So I can't say this enough. Remember, I is root -1, and I squared is equal to -1. Now, it really goes counter to everything we've been teaching you all these years, right? We've been saying that anytime you have a squared number, it's going to be positive. Well, in this case, for imaginary number I squared equals -1. Okay, last part, solving equations with complex numbers. Now we have the skills we need to really get to the whole point, which is solve an equation where we're going to end up with a complex number. So we're going to get 3x squared, and I'm going to move over that 48. Now I'm going to divide both sides by 3. And -48 divided by 3 is -16. Now I'm going to take the square root of both sides. So I'm going to end up with x equals plus or minus. Be careful when we take the square root of both sides, we get plus or minus. We know we have an I in our answer because we have a negative under the radical, and the square root of 16 is 4. So we end up with plus or minus 4i. Pause the video, try it, come back when you're ready. We're going to move over the negative 150. We're going to divide by -5. We're going to take the square root of both sides. Final answer, x equals plus or minus I root 30. Okay, everyone, that's all I have for this lesson. Thanks for watching. Have a great day.